Are we rolling? Yes, we are. Ew, I look gross today. All right. Is my sound working? Check, 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 check. I'm going to say yes. Okay. 5.4, applying systems of equations. Now, the principles in this lesson are things you've already done before with certain word problems. I don't know why they're introducing it like a new topic, but they are, which is part of the reason why I put 5.1 through 5.3 together, because it was 3 different ways to do something we already knew how to do. So let's just do it the simplest way to think about. 5.4, it's pretty much just a recap. It's just not as wordy. There's not as many word problems we're working with. We're just working with the numbers and value, the math, the language of math instead of the language of English. So really just going to use this lesson to run through some more examples for you here. Yeah. And it's going to be very important that you know how to do the word problems at the end of this chapter. All right, so let's start with page 173. Your homework is the odds, so I'll just run through a few of the evens. Try saying that 3 times fast. Ice cream. Sponsored by Mayfield. Okay. Question 2. Find two numbers whose difference is 38 and whose sum is 78. What is known, what is unknown? Well, we know that the difference is 38. And what does difference mean? It means we're dealing with a subtraction problem. Subtracting what is the question? Two numbers. We don't know what those numbers are, so let's just call them A and B. So the difference of two numbers is 38, and the sum of those same two numbers is 78. Sum means add. So A plus B equals 78. All right. I mean, there's strategies in these lessons that would make this problem quicker, and I actually see what they mean right now. But the point is, we don't need to use it because we can just do it the ways we already know how without complicating it with a layer. So what we want to do is we want to get one of the variables by itself in one of the problems. So let's go ahead and get A by itself. Let's add a B to both sides, plus B plus B. That's going to give us A equals B plus 38. And now that we know what A is, we can go back to this problem over here and do a substitute. A equals B plus 38, so that's subbed in. Everything else is the same. Combine like terms. Well, there's nothing to distribute on the parentheses, so we can drop them. Combine like terms. We got a B plus a B is 2B plus 38 equals 78. Dang, what's going on? All right. 2B minus 38 plus 38. 78 minus 38 minus 38. 2B equals 40 divided by 2. B equals 20. And if B equals 20, let's go ahead and substitute back in to our upper problem over here. Minus 20 equals 38. That would mean A equals 58. All right, beautiful. Let's go to another example. All right, this one's a little complicated, which is why I wanted to do it. This is number 4. Separate 39 into 2 parts such that 4 times the smaller exceeds the larger by 6. Now, the way this is worded is kind of ambiguous, but separate just means split into 2 numbers, but the numbers will add together to the 39. So, for example, split it into 30 and 9. That's what they mean by separate. It's weird. It's not a normal thing you would hear in English, but it's what it wants in the math world. So we're going to split 39 in 2 numbers. The 2 numbers are going to add up to 39 still. So that's one sentence right there. And for our letters, let's use S and L because it says in the question the smaller and the larger number. So there's going to be a smaller portion and a larger portion. Okay, and it says the smaller exceeds the larger by 6, or 4 times the smaller. 4 times the smaller is 6 more than the larger. So the larger plus 6. All right. So now we got ourselves a problem. Or we got 2 variables and 2 sentences, so we know we can solve. So this is what a system of equations is. Just more than one equation that work together. So let's get L by itself in this bottom one, minus 6 minus 6. It's going to give us 4s minus 6 equals L. That's going to give us our substitute in this problem over here, where s minus 6 equals 39. Distribute the positive through, that gives us the same signs that were already there. All right, combine like terms. 1s plus 4s's is 5s's. Plus 6 plus 6. It's going to give us 5s equal to 45 divided by 5 divided by 5. S is going to equal 9, so the smaller number is 9, and if they add up to 39, that means the larger is going to be 30, and if we look at our other condition, 4 times the smaller, 4 times 9 is 36, and that is 6 more than 30, so our 2 rules are met. All right, we are on question 10. The size of 2 complementary angles is in the ratio of 1 to 3. Find the 2 angles. So this takes us back to trigonometry a little bit. Complementary angles are angles that add up to 90. So that gives us our first sentence right there. The first angle plus the second angle is equal to 90. Now it also says the angles are in the ratio of 1 to 3. And that's kind of funny because it sounds like 1, 2, 3, but it's 1 to 3. Okay, so that means one angle is going to be 3 times larger than the other angle. So that's another sentence right there. Angle A is 3 times larger than angle B, but remember we have to think about when it's worded like that. So that means 3 times angle A is angle B. So 3A equals B. Beautiful. We already have something we can substitute since B is by itself. So let's go ahead and do that. A, substitute that from down there, equals 90. That gives us 4A equals 90. Divide by 4, divide by 4. A equals something 22.5. And that means that angle B would be 3 times larger than that, which should be something like 67.5, and yes, I did look in the book to confirm as opposed to working out. But beautiful, they both add up to 90, but if you make it a ratio, that's 1 and that's 3. Meets our conditions. I'll do one more. All right, we got a complicated one. How many pounds of each dried fruit selling at $3 per pound and $3.80 per pound must be mixed to make a mixture of 80 pounds to sell at $3.50 per pound? All right, what are our knowns? What are our unknowns? Unknowns, we got 2 types of fruit. Let's call them apples and bananas so we can use A and B. Now, it's important in the context of this problem, A does not equal apples. A is going to equal pounds of apples. A equals pounds of apples, and B is going to equal pounds of bananas. And the reason I know that, oh, I just used 2 different, that's a little annoying, pounds of bananas. And the reason we know that we're using pounds instead of per item is because that's what the problem's talking about. It's talking about, that's what it's asking for, how many to make 80 pounds. Pounds, pounds, pounds. It's not talking about individual fruit. So that's how we know what our variables are talking about. So first thing we know, the mixture is going to equal 80 pounds. So that means the pounds of apples plus the pounds of bananas is going to equal 80. That's easy. Now, the other one is talking about price per pound. Oh, sugar. Undo. Too much. Too much. All right. So now we're talking about the prices per pound. So there's a couple different routes we can take it. But let's just think of the value of the pounds of the apples and bananas. So Remember, value is going to be multiplying the individual price times the quantity is going to give us the value. So the value of apples is going to be the number of pounds of apples times the price per pound of apples, which is going to be 3A. So that's going to give us our total value of the apples, and our total value of bananas is going to be the 380 times the pounds of bananas. Now, to get the total value of the bag, we're going to add, or of the mixture, we're going to add these two things together. So that's going to give us the total price of the bag. Now, it's not asking for the total price, it's asking for the price per pound. So the price per pound is going to equal $3.50. Okay? But right here, we just have the price. To get price per pound, what do we got to do? Well, what does per mean? Per means divide. So here's the price per pound. How many pounds is this mixture going to have? 80. Beautiful. Now, we got two sentences with two variables, which means we can do some substitution. Let's get our apples by themselves. Do we want apples by themselves? Yeah, we want apples by themselves. So apple minus b is going to give us a minus b plus 80. That's my phone. All right, I forget where we were. Because I was on a phone call. All right, somewhere over here probably. All right, yep, there. That's what a equals. So we can substitute. Oh my goodness, this looks ugly. Well, we got ourselves a fraction. Let's clear the fraction. Multiply both sides by 80, 80, 80, boopity boop, boopity boop. Cancel, cancel. That's going to equal something. 3 times 80 is 240, plus half of 80 is 40, so that should be 280. Or it should be, yeah, 280. 280. If I'm wrong, let me know. And this is going to equal 3a plus 3.8b. Substitute the a. That's a plus sign right there. Substitute a. 3 times negative b plus 80 plus 3.8b equals 280. All right, and I'm going to clear the frame, and we'll go from here. All right, picking up where we left off, distribute the 3, negative 3b plus 240 plus 3.8b equals 280. 80. Combine like terms. Negative 3b plus 3.8b is going to equal 0.8b plus 240 equals 280 minus 240 minus 240 is going to give us 0.8b equals 40. All right, divide by 0.8, divide by 0.8. The b equals, and let's take a look. First of all, we want to get rid of the decimal, so let's multiply everything by 10. So that's going to give us 400 over 8. And now, like terms, 8 goes into 8 once, 8 goes into 45 times, and that extra 0 gives us 50. So the number of pounds of bananas is going to equal 50 pounds, which means the number of apples is going to equal 30 pounds. All right, that's good stuff. If you have questions, write them down. That's what the spot in your lesson guide is for, writing questions so you can ask me. Okay, so please do that, because I know some of these things might have been confusing. So write down your questions and ask me at CarMath. All right, that is all. Bye.